Good morning, 6th grade. So this video is for Thursday, May 7th. I'm going to read you, I'm not really reading you a story, but I'm going to read information from a book for you guys because it's science, so you guys, it's got to be informational text. So my book that I have is Everything You Need to Know You Need to Ace Science in One Big Fat Notebook. So it's actually created by the makers of BrainQuest, and it literally has like everything that you need for middle school science from 6th through 8th grade. So like I literally like sat there and like sifted through it. So like most of chapter 16 is basically what I was teaching you guys this week. So pretty much everything that I taught you guys this year is in here, plus the stuff you guys will learn in 7th and 8th grade. So this is a cool book to get for studying, and it might even be helpful for the 8th grade FSA for you guys to study, to know the knowledge that you guys need to know. So anyway, so I'm just going to read a couple of pages. I'm sure you're not going to find it that interesting. I'm not that concerned with that, but it's going to be quality content that you guys need to know for this topic. Okay, so I'm starting with chapter 26, weather. Weather refers to the condition. I lie. I'm not going to read this page, but I am reading from chapter 26. I'm going to read the next page because we were not talking about weather, and we really weren't talking about air density either, but we were talking about global and local winds, and global and local winds affect our weather. So global and local winds. Uneven heating of air in the atmosphere creates air temperature differences. Air that is warm expands and therefore is less dense and has lower pressure than colder air. Wind is the result of the air pressure and density differences caused by warm and cool air. Air flows from high pressure areas to low pressure areas, creating wind. Global winds. Differing air pressures around the world cause winds that loop across the planet. The sun's rays strike the earth more directly near the equator than near the poles. So the air heats up more near the equator than the poles. Therefore, warm air from the equator rises and moves toward the poles, while cold air from the poles moves toward the equator to replace it. The Earth's rotation is combined with these differing air temperatures causes the movement of air from the equator and the poles to curve in different directions. This is called the Coriolis effect. The Coriolis effect causes winds to curve to either east or west, creating predictable wind patterns in different parts of the world. The trade winds near the equator are called trade winds because early sailors used them to navigate trade routes. So this is very similar to the picture that I put in some of my PowerPoints this week and last week, and how the sun affects the way the currents go. Jet stream. Although some winds blow at the Earth's surface, there are also high altitude winds which are located in the upper troposphere, which is the bottom part of the atmosphere. In North America, the global jet stream is formed at a boundary between cold and dry air from the North Pole and warmer, moist air from further south. The air temperature differences cause the jet stream to be very strong, up to a steady 250 miles per hour, which usually blows from west to east. Local winds. There are daily breezes where the ocean meets the land because land cools and warms faster than water. Water stays nearly the same temperature day and night. Land is heated during the day, which heats the air above it through conduction. This warm air rises, causing convection currents with cooler air from the ocean. During the day, cooler air causes air to move. Wow. During the day, cooler air moves ashore and is called a sea breeze. At night, air above the ocean water is warmer than the air on land, so it rises. The resulting convection current forms a wind that moves out into the ocean from the land, called a land breeze. Local lands are also caused by topography, like the different temperatures in the valley or wind funneling through the mountain pass. So I didn't really talk about humidity, but I'm going to read this little paragraph about humidity to you guys because that was actually part of your lesson. Humidity is the amount of moisture and water vapor in the air. Usually the humidity level is reported in relative humidity, which is the amount of humidity in the air compared to how much the air can hold. When air is at 100% relative humidity, the air molecules are completely saturated, which means they can't hold any more water vapor. And I have one more part to read to you guys about El Nino and La Nina. So once in a while, the seawater in the Pacific Ocean cools down or warms up more than usual. The unusual warming is called El Nino, and the cooling is called La Nina. During the El Nino years, the trade winds soften, so the water in the Pacific Ocean doesn't move as much from east to west, and thus very little cold water can surface from below. This causes the water along the west coasts of North and South America to be warmer than usual. The change in the ocean temperature brings rainfall that causes flooding in some regions and droughts in others. During La Nina years, the opposite happens. The trade winds are very powerful and they push the warm water from the West Pacific farther westward. As a result, a lot of cool deep sea there's a fly in front of my face. As a result, a lot of cool deep sea water surfaces. Weather in the US is usually drier than during La Nina years, although it varies by location. Okay, so that's my information for you guys this week from my book. I'm going to definitely use it for the next couple of weeks. Maybe I can find something cooler to read to you guys. Anyways, I will see you on Zoom at 11 o'clock. Bye!